I am going to attempt question 1, and this question 1 is from the 2022-2023 exam, question 1 of part of section B. So as you can see, the questions seem to be recurring. Even the previous exam had similar questions. So you could just have to grab either one of either this 2022-2023 exam or the previous one, and you'll have solutions to the same question, because they just keep bringing back the same questions. So question 1 part A says, what is an abstract class? So an abstract class is an incomplete class that cannot be instantiated. One mark for incomplete class, another mark for cannot be instantiated. Those are your 2 marks. So I can demonstrate what an abstract class is by creating a simple class called abstract. And to make this class abstract, all I have to do is use the keyword abstract. Remember, the keywords are case sensitive, so it doesn't have to be capital A. It has to be lowercase a. So this is an abstract class. And to demonstrate that it cannot be instantiated, all I have to do is declare abstract like that. I'll create an object of type abstract class, instantiate it like this. Abstract like that. So we cannot instantiate an abstract class like this. As you see, there's an error here, and it is saying the class abstract is abstract and it cannot be instantiated. Okay, so that's part A. Part B says, why should a final method never be abstract? That's an interesting question, which was not in the previous one. Why should a final method never be abstract? Because first of all, you cannot override. Oh yes, you cannot override final methods. So if you make an abstract method final, you are locking the method from being what? Overridden. Because when you implement these methods, these abstract methods, they must be overridden. And if you make a method final, you're locking it from being what? Overridden. So let's demonstrate that. Let's create an abstract method, public void abstract, and let's call it override me. So that's an abstract method. Why is this complaining? Public void abstract. Oh, okay. Public abstract void. Okay, abstract comes first. So public abstract void override me. Let's get rid of this code. So when we have a class somewhere below, a class called another that inherits this abstract class called abstract, like this. So this will cause an error unless we override the method, the incomplete methods. In other words, the abstract methods have to be overridden within this concrete what? This concrete class. And if you make this final, like this, it's complaining here, illegal combination. Okay. If you make it final, then you cannot override the method like this public void overriding. So this won't work. IntelliJ is already complaining that this is not allowed, saying this is an illegal combination of modifiers because you should not be doing this anyway. So even if you put it here, it will still be an illegal combination. So you cannot make an abstract class final. So what they were testing for here is if you make let's not make this abstract and demonstrate why this must not be final when you want to override. So see, when you are overriding a final method, it will not override because being final locks the method from being overridden. So it is only I just made it empty with an empty body like this with no implementation just to demonstrate. So if you remove the final keyword, then it unlocks the method from what? It unlocks the method for overriding. So then here you can implement some other stuff that you want to do. But when you make a method final, you're locking it from you're locking it from being overridden here. So here it is saying override me cannot override me in abstract because the overridden method is what? It's final. So that's what the question was testing for. Even though doing it like this is an illegal combination, it's not allowed in Java. But the takeaway is final methods cannot be overridden, and that's the answer you should be filling in here. Why should a final method never be abstract? Because final methods cannot be overridden. So let's get rid. Okay, let's just continue to the second question. And the second question is asking us to write down 2 ways how a class can become abstract. So the 2 ways a class can become abstract are, let's use this very one. So let's get rid of this. Let's get rid of the main and that. So the first way a class can become abstract is when we declare the abstract keyword up there in the class declaration. So that's one way. The other way a class can become abstract is if this is a concrete class like that, and this class has an abstract method. Abstract method like this. Abstract methods don't have a body, so like this. Abstract comes first after the modifier, like that. So this is complaining because we are having an abstract method in a non-abstract class. So the second way to make a class abstract is by declaring abstract methods in that class, which will force us to make the class what? Abstract, like this. And then the error goes that way. Then the third way could be if we have a subclass which extends this abstract class of ours, like that. So this class is extending, this subclass is extending the abstract class, which is abstract. So another way to make this class abstract is by extending is by extending an abstract class, which will force us to make the subclass abstract, like that. And this is not compiling. Why? It has to come first after the modifier, the default modifier. So abstract class like that. So that's the third way of creating an abstract class. So here they asked for two, so you have three ways. And let's go down to D. Assume that T is an abstract class. So let's go and assume we have T, which is an abstract class, and it is abstract because we need to, after the modifier, declare that it is abstract. So that's our T. For each of the following, indicate true or false whether the code causes an error and give a reason for your answer. So the first part is, if you have something like this, T object 1 is equal to new T, will that cause an error? This being an abstract class, this T being an abstract class. So this will cause an error. So the answer here is true, because when we try it ourselves and say T obj1 is equal to new T, like this, T being abstract, this will cause an error. So here it is true, it will cause an error. And the reason is T is an abstract class, and abstract classes cannot be instantiated. That's what we have. That's what we have. That's the reason. Then part 2 is saying we have an array here called ARR, and it is being instantiated with a size of 5. Can we do this? Will this cause an error? And the answer here is false. This won't cause an error. Let's try it out so you can see. So we have T is an array here like that, and it is holding 5 elements. This is new like that. And that's what we have. So this is not causing an error, so it's false. And the reason is, what's the reason? T can be used to create an array. That's the reason, because you can see we are not getting an error. And part E is using an example of your choice. Demonstrate polymorphism by using one abstract class that has at least one abstract method and two concrete classes that inherit the abstract class. The main method is not necessary in any of these classes. So they want us to demonstrate polymorphism using one abstract class which has at least one abstract method. Okay, so let's go to our project file here. Let's create a class called poly, and this class has to be abstract. So after the modifier, you declare that it is abstract, and our class also must have at least one abstract method. So let's call this one like this. That's our abstract method. And then they're asking us that we should have two concrete classes that inherit the abstract class. So two concrete classes that have the abstract class poly as their superclass. So let's have poly A extending poly like that. And once we extend poly, then we are forced to either make this class abstract like this, or we have to implement this method this method up here, which we have to do because this class has to be concrete. It must not be abstract. So to implement that method, we need to override, and then just use this method up here, this public void 1. So basically just get everything here except the keyword abstract, because when we make it abstract here, then it ceases to be an override, because overriding means you are going to provide an implementation. But when we make it abstract, then it ceases to become a complete method. So we need to get rid of the abstracts and just use these other modifiers, public void and the method name, which is 1. So let's provide an implementation for this method and say this will print out 1. So that's the first class, the first concrete class. This first concrete class is not abstract. That's what makes it concrete. It makes it complete, a complete class. So the next concrete class we can have is poly B, which extends poly. Poly is our super class that is abstract. And then do the same, because we need to override this method here. So by doing that, you can provide another one like that, another implementation of the same method, this one here. And I believe that is all. The main method is not necessary, so we don't need to create any main method in any of these classes. And that is part E, demonstrated. We are demonstrating polymorphism, but let us demonstrate polymorphism so you see what it means actually. Because poly means many, and morph is form. It means form. So many forms is what they want us to demonstrate. So how do we demonstrate that this method here is polymorphic? How do we demonstrate that it has many forms? So let's create a main method down here, and we shall create an object of type poly B, and this object will be poly B is equal to new poly B, like that. Let's do this, and then our poly B object is going to call the method 1, like that. So this poly B object is going to call the 1 method, but this 1 method is going to be this one that was implemented in what? In the class poly B. That's the one we are going to call. So running this code should print out what? Another one as the output. Okay, so let's make sure we have no errors and run this again. And we get another one being printed out. Let's move this to the right top like that. So how do we demonstrate polymorphism? We have to make sure that we use the same method call but in a different context. So I'm going to create another object of type poly A. Call it poly A is equal to new poly A, like that. And this object of ours, poly A, is going to call the method 1. So this method 1 called on this object poly A of type poly A is going to call not this one, but rather this one, this method here defined in what? In poly A, because we are calling a method on an object, and this object is of type poly A, and poly A has an implementation of that same method that we are calling, called 1. So it's going to use this implementation, not this one. It's going to use this one because depending on the context here is of what? Poly A. So we are going to use the implementations of what? Of poly A. So we shall have, when this code runs, we shall have another one and one being printed. So this will demonstrate polymorphism because we have a method called one behaving differently depending on the environment or depending on the context. So here it is printing another one, but when we use it here, it is printing one because the context is not what? Is not the same. Here it is referring to an object of type poly B, and here it is referring to an object of type what? Poly A. So the context is different, and that is what? Polymorphism. Same name and different meanings, you should say, or same object, different forms, something like that. And that is question 1 answered.